The next part of lesson 1.4 in day 2 is graphing quadratics. We'll look at the different forms of a quadratic equation and the key features used to graph them. Where it says types of quadratics and how to graph, let's put a little kind of asterisk over here. These will be our key features. We'll first start with standard form and then move to vertex and factored form. Okay, let's first start with standard form. Standard form for a quadratic function models the form y equals ax squared plus bx plus c. So we haven't split it apart into the factored components. There are 4 key features when graphing in standard form. The first thing you want to do is always calculate your vertex. The vertex is an ordered pair. To get the x-coordinate, we use the coefficients from our equation. X equals the fraction negative b over 2a. That would be the first thing you would calculate. Once you get that answer, to get the y value, you just plug x back into the equation and then simplify. Remember to write your answer as an ordered pair. Once you have that, the axis of symmetry is easy. It's the same as the x-coordinate of the vertex, so we use the same formula. X equals negative b over 2a. The key with an axis of symmetry is you have to write it as an equation, like x equals 1/2 or x equals negative 3. And then you draw a dashed vertical line right through the middle of your graph. The third thing you'll need is the y-intercept, and the y-intercept is easy as well. If you look at the equation, the last number is called a constant, that's c value. Well, to find the y-intercept, if you plugged in 0 for x, everything but that constant cancels out. Therefore, 0, c is the y-intercept. Last but not least, just to give you kind of something to connect with on the other side, we have a reflection point. You literally take that y-intercept and you reflect it over the line of, or over the axis of symmetry and plot its reflection on the other side. You should now have 3 points that you're able to connect through to form the shape of that quadratic function. And this is how you graph in standard form. Our next form is called vertex form. And it's called vertex form because you can use the actual equation to generate the vertex without having to actually calculate it, which is kind of nice. The form you'll see is a squared parenthesis this time instead of just a squared x value. So it models the form y equals a times x minus h squared plus k. This is also known as a transformation of the parent function. To get your key features, we start with the vertex again because this is really easy. In the formula, whatever's in the parenthesis with x, that h value, we change its sign for the x-coordinate of the vertex. And then whatever's added or subtracted after, we keep it the same sign, and that's the y-coordinate. Notice we say that it's h, k. And again, write it as an ordered pair. Your axis of symmetry is still easy to find. It's the same as that h-coordinate. And again, like in standard form, it has to be written as an equation. The y-intercept is where you're going to have to show some work on this one. You have to actually plug in x equals 0 and then simplify the equation. Watch your order of operations here. This can be kind of tricky to simplify. Once you plot that y-intercept, we do our reflection point again, just like standard form, to get that point on the other side. And then we'll draw our curve through that quadratic function. These are the key features into a graph in vertex form. Our final form will be more unique than the first two. Factored form is when you have your quadratic function split into a product of smaller parts. When it's in factored form, our key features are found a little bit differently. The first thing we'll do, instead of finding the vertex, is we'll actually determine the x-intercepts for that factored form, just like we did when we worked on solving in 1.4 day 1. If you have it in factored form, your x-intercepts are the p and q values, and like before, they're opposite signs. So that's kind of like vertex form. Once you have your x-intercepts, to get the vertex, we find x by just taking the average, p plus q divided by 2. Once you know your x-coordinate, to get the y-coordinate, plug x in and simplify. And again, make sure this is an ordered pair. Once you know your vertex, the axis of symmetry is the same as the x value. So it's x equals p plus q divided by 2. And like in vertex and standard form, that must be written as an equation. Last but not least, our y-intercept. This one is optional this time. If you need an additional point to plot just for guidance on the shape of your graph, you can plug in 0 for x in both parts of the parentheses and then simplify. But this one is optional. If you have enough points with your x-intercepts and your vertex, then that's all you would need to sketch your graph. These processes should be fairly straightforward with every example we look at. However, sometimes when you're graphing, the information above just doesn't quite give you enough points. When that happens, you can make a table and plug in additional points. And that's a rare occasion. That won't always happen. All right, let's put this to the test, everybody, and try some examples for graphing quadratic functions. For each equation, determine the form that it's in. Then state the key features and sketch the graph. How many of you remember what the name of the graph is called? We'll say the shape or name of the graph is a parabola. So if you're wondering why we haven't said that a lot, that's just the name of the shape. The equation itself is quadratic. Let's try example A. F of x equals x squared minus 6x plus 10. Based on the form that it's in, that models standard form. So that's the first thing we'll say. We are in standard form. Once you know the form you're in, follow the rules in the chart up above to determine those key features. The first thing we'll look at is the vertex. To get the vertex, we follow the steps for x and y. X equals negative b over 2a. Since b is negative 6, that's going to give us a double negative. Over 2 times a, well, if the number in front of x squared technically isn't written, it defaults to 1. So it's just 2 times 1. And now we simplify. A double negative makes positive 6 on top. 2 times 1 is 2 in the denominator. 6 divided by 2 is 3. That's our x coordinate for the vertex. To get y, we plug x back into the equation. It's x squared minus 6 times x plus 10. And again, simplify. 3 squared is 9. 6 times 3 is 18 plus 10. 9 minus 18 is negative 9 plus 10 equals 1. That's our y coordinate. And we write our vertex again as that ordered pair. All right, let's go ahead and plot that point 3, 1 over in quadrant 1. That's all the work we do. The rest of the steps are just from the information we've already calculated. 2 is our axis of symmetry. And that just shows kind of the middle of our quadratic function, or the middle for the shape of our parabola. And the axis of symmetry is the same as the x-coordinate for our vertex. Since x was 3, the equation is x equals 3 for our axis of symmetry. I'm going to draw that in blue on my graph. It's a vertical, just kind of dashed line, and it goes right through that vertex from bottom to top. And everything on the left and right is a symmetry for this quadratic function. All right, part 3, our y-intercept. Again, no work for this one. The y-intercept is always that constant in the equation. If we were to plug in 0 for all of our x's, that's all that would be left over. Our y-intercept is 0, 10. We'll plot that point on the y-axis, all the way up to the top. And then step 4, we reflect it. And what I mean by that is notice that it's 3 units away from the axis of symmetry. So we'll reflect it to the other side by counting 3 units to the other side, over here on the right. And that's all you do for that reflection point. It's really that easy. From here, we notice that the vertex is down below and these 2 points are up above. What we'll do is we'll draw a curve, not a V shape, but try to make it a curve through all these points with arrows at the top. Something like this is the shape for our quadratic function, x squared minus 6x plus 10. This is our first parabola in standard form. Let's move on to the next example. Our next equation, y equals -2 times x plus 3 squared plus 4. Looking at our three forms up above, this models vertex form. So that's the first thing we'll identify. It's just the form that our quadratic is in. And then we'll just follow that column for key features. In this form, the vertex is easy to calculate. It's the numbers literally that are in the equation. Whatever's on the inside with x, we always switch the sign. So we'll make that -3. Whatever's on the outside, we keep the sign, +4. No kidding, that's the vertex. -3, +4. Go ahead and plot that point over in quadrant 2. From here, the axis of symmetry, again, easy. It's the same as that x coordinate, x equals -3. And this time I'll graph it in green. That vertical line just right through that vertex, all the way from bottom to top. There's your axis of symmetry. Now the y-intercept is where we have to show a little bit of work. When we plug in 0 for x, we don't get an output of 4. So that last number isn't our y-intercept. Watch how that happens. When we plug in 0, we have to think order of operations. Oh, I know. There we go with that again. Order of operations on the inside. 0 plus 3 is 3, but 3 squared is 9. -2 times 9 is -18. And when I add 4 to that, oh, our y-intercept is -14. That's really far off of our graph. So that's too low. We could try to get it to fit down there, but it's pretty low to the edge of our paper. So what we'll do instead, to find our reflection point, that would still be off of our paper, we have to default to making a table. All right. This isn't bad, it just takes a little bit of work. And we'll pick just enough points to show up on our graph. What I mean by making a table is we're literally going to make a table with x and y coordinates. We'll pick x coordinates and then plug in to find our y coordinates. We already know when x equals -3, the graph has an output of 4. So using this number kind of as our guide, I'm just going to count 1 to the right. I'm going to plug in -2 to the equation. So if I plug in -2 for x, I would have y equals -2 times -2 plus 3 squared plus 4. And again, just simplify order of operations. -2 plus 3 is 1, and 1 squared is 1. So if I do -2 times 1, that's -2. Plus 4 would be +2. Now that's a point we can plot on the graph. Go to -2, +2. And then if I reflect that to the other side, -4, +2 is another point. So we got that one kind of as a freebie. Let's try another one. Let's plug in -1. So I'll just go 1 more to the right on the x-axis. If I plug in -1, we have -1 plus 3 on the inside. -1 plus 3 is 2, and 2 squared is 4. So if we take -2 times 4 and then add 4, -2 times 4 is -8, plus 4 is -4. That will fit on our graph. So I just went to -1 down -4, and if I reflect that one to the other side, can you start to see the shape of our parabola forming on the graph? Now those points are all below the vertex, so our parabola is going to open upside down. Draw a smooth curve through all those points. And there you have our second quadratic function in vertex form. So let's take a moment just to review these two methods, and we'll try the next video. So when you're ready, go ahead and watch the second part of the video, for this part of the lesson 1.4, day 2.